back. So in this chapter, we're going to cover intelligence, reasoning, creativity, and wisdom. So we'll first explore how people define intelligence in their daily lives and the components of the lifespan approach to intelligence, as well as the major research approaches used to study this complex concept. First, let's consider how intelligence is perceived in everyday situations. And this perception can vary widely based on context and cultural influences. Research by Robert Sternberg has significantly contributed to our understanding of intelligence, and he argues that it encompasses more than just a fixed set of traits. In his investigations, he gathered input from everyday observers. And so these were people at locations like train stations, supermarkets, and college libraries. They identified behaviors that they believed characterized individuals who were exceptionally intelligent, academically intelligent, everyday intelligent, or unintelligent. Sternberg then presented these behaviors to both experts in the field of intelligence and another group of lay people. Each group was tasked with rating how distinctively characteristic or important each behavior was in defining the four types of intelligence. And the analysis revealed a consensus between experts and lay people, and both groups identified three key clusters of abilities that comprise intelligence. One was problem-solving ability, which includes behaviors such as logical reasoning, recognizing relationships among ideas, understanding all aspects of a problem, and making sound decisions. Second was verbal ability, which encompasses skills such as articulate speaking, high comprehension in reading, and possessing a rich vocabulary. And then third was social competence, which covers behaviors such as accepting others, admitting mistakes, showing curiosity about the world, and being punctual. An important study conducted by Berg and Sternberg in 1992 aimed to examine how these conceptions of intelligence vary across the adult lifespan. Participants ages 22 to 85 were asked to rate 55 behaviors they believed were characteristic of exceptionally intelligent individuals at ages 30, ages 50, and ages 70. The findings revealed that certain behaviors such as motivation, intellectual effort, and reading were deemed important indicators of intelligence across all ages. However, specific behaviors were associated with particular age groups. For example, traits such as planning for the future and open-mindedness were most frequently noted for 30-year-olds, while intelligent 50 to 70-year-olds were characterized by their sense of responsibility, adaptability, verbal fluency, and wisdom. And so what's fascinating is that despite the variations in age, there is a strong consistency in how people recognize intelligent behaviors throughout different life stages. This consistency raises important questions about how these perceptions align with systematic psychological research, which we will talk about next. So we're going to talk about how intelligence is viewed as a complex idea. There are theories of intelligence that have four main concepts. And one is that intelligence is multidimensional. People generally agree that intelligence is not just one thing. It includes various abilities that work together. And while there is some debate about how many types of intelligence there are, it is clear that no single type accounts for all of the mental tasks we perform. Baltes and his colleagues have provided a broad perspective on intellectual development, emphasizing that our understanding of intelligence changes over time. The second concept is multidirectionality, and this refers to the different patterns of change in abilities as we age. Different skills can improve, decline, or stay the same at different rates. So, for example, while everyday knowledge tends to grow as we get older, some basic cognitive skills may decline, especially in later years. There is also plasticity. Plasticity describes how flexible our abilities can be depending on our experiences and practices. So this means that some declines in skills may be due to not using them enough rather than an inability to improve. Research shows that our brains can adapt throughout our lives, and older adults often activate different areas of their brains to help make up for any declines in performance. And this ability to adapt can lead to better outcomes than we might expect. And so far, these are essential to this view of how intelligence can evolve throughout our lives. The last one is inter-individual variability. And this highlights that people develop their intellectual abilities in different ways. Research shows that within a single group of people from the same generation, some may experience declines in certain abilities, while others might maintain their skills or even improve them. So adults differ in their direction of intellectual development, and this variability suggests that average changes may not accurately represent everyone's experience. And so understanding these theories of intelligence means that we're looking at intelligence as a complex and evolving set of abilities that are influenced by our age, our experience, and our individual differences. The dual component model of intellectual functioning was proposed by Baltes and his colleagues. And this model suggests that there are two interconnected types of processes that shape our intellectual development. One is the mechanics of intelligence, and this component refers to the basic structure of our minds and brain. It includes the foundational abilities we need for thinking, such as attention, reasoning, spatial awareness, and how quickly we can perceive information. Changes in this area are most significant during childhood and adolescence, when our brains develop the connections necessary to tackle complex tasks. The mechanics of intelligence are driven by biological and genetic factors, and these tend to decline as we age. And so it's subject to an overall downward trajectory across adulthood. Pragmatic intelligence is the second component, and this involves the knowledge that we gain from culture and our experiences. And this includes practical skills, verbal knowledge, and wisdom. These abilities are shaped by our social and cultural environments. As we move into adulthood, growth in pragmatic intelligence becomes more prominent as we learn and adapt throughout our experience. And so this type of intelligence is influenced more by our environment and often continues to grow throughout adulthood. And so while mechanics of intelligence tend to fall downwards, pragmatics of intelligence tend to maintain an upward trajectory. This is a diagram showing the lifespan conceptualization of the mechanics and pragmatics of intelligence. The mechanics of intelligence correspond to fluid intelligence, and the pragmatics correspond to crystallized intelligence. Historically, research on intelligence has looked at how people perform on standardized tests. And this is a perspective known as the psychometric approach. And so it's measuring intelligence as a score on a standardized test. And so these tests focus on getting the right answers, but often overlook the thought process used to reach those answers. So this is the kind of assessment many of you have encountered in school when taking standardized tests. This approach has faced criticism for revealing performance gaps among different cultural, racial, and ethnic groups. Other researchers take a different approach by examining information processing mechanisms, and this perspective aims to analyze in detail how cognitive functions like attention and memory change with age and how these components interact. Additionally, some researchers are redefining intelligence and what it means, and how we measure it by using a more cognitive structural approach. This method focuses more on how people understand and solve problems rather than just on test scores. It emphasizes the developmental changes in thinking styles and how these affect everyday life. The organization of interconnected intellectual abilities is referred to as the structure of intelligence. One common way to visualize the structure is as a hierarchy. Each level in this hierarchy represents a more complex organization of the components found at the level below. At the lowest level, we have individual test questions, which are the specific items people answer on intelligence tests. These questions can be grouped together to form intelligence tests, which make up the second level. The third level involves the relationships among scores on these tests, reflecting clusters of abilities known as primary mental abilities. As we move up the hierarchy, the interconnections among these primary mental abilities lead to the formation of secondary mental abilities at the fourth level. At the very top, we find general intelligence, which represents the relationships among the secondary mental abilities. It's important to note that as we ascend this hierarchy, we step away from actual performance. Each level above the first is a theoretical description of how different elements fit together. This means that there are no direct tests for primary abilities. Rather, these represent theoretical relationships among the tests themselves, which are based on actual performances. So, researchers tend to create this theoretical hierarchy, and they use a method called factor analysis, which involves sophisticated statistical analyses. And the researchers first collect data on how people perform on a wide range of problems, and then they analyze the results to see if performance on one type of problem, like completing a word by filling in missing letters, will predict performance on another type, such as unscrambling letters to form a word. If there is a strong relationship between the two performances, the abilities measured by these tests are considered interrelated, and they are referred to as a factor. Researchers have recognized that intellectual abilities can be examined as groups of related skills. And these skills are organized into primary mental abilities and secondary mental abilities. For primary mental abilities, these are hypothetical constructs into which related skills are organized. And so from these primary abilities, related groups then can be further clustered into the broader categories. And these are what's known as secondary mental abilities. And so they're related groups of primary ones. There's been about roughly 25 primary mental abilities that have been identified. And since studying all of them can be challenging, researchers have focused on 5 key representative abilities. So one is number, which refers to the basic skills that underlie mathematical reasoning. Second is word fluency, and this measures how easily we can produce verbal descriptions and express our thoughts. Verbal meaning relates to our vocabulary and our understanding of words. Inductive reasoning is an ability that allows us to extrapolate general concepts from specific facts. And spatial orientation involves our capacity to think and reason in three-dimensional space. And so even with this small selection of primary mental abilities, it remains difficult to discuss intelligence by looking at each ability in isolation. And so therefore, theories of intelligence tend to emphasize clusters of related primary mental abilities to describe the overall structure of our intelligence. It's also important to keep in mind that because secondary mental abilities are hypothetical constructs, they are not measured directly, and instead they provide a framework for understanding how different abilities are interconnected. So these are some of your secondary mental abilities, and so they're categorized in your textbook I didn't have all of them listed on here, but visual organization, which is indicated by primary mental abilities such as visualization, spatial orientation, speed of closure, and flexibility of closure. Auditory organization includes primarily mental abilities of temporal tracking, auditory cognition of relations, and speech perception. Crystallized and fluid intelligence are also categorized under this as well. Fluid intelligence refers to your ability to think flexibly and adaptively. It helps you make inferences and understand how different concepts relate to each other. This type of intelligence is especially important for dealing with new situations and includes skills like inductive reasoning, integration, and abstract thinking. On the other hand, crystallized intelligence is the knowledge you gain from life experience and education. This includes your general knowledge, understanding of communication, judgment, and ability to work with information. When we look at how fluid and crystallized intelligence develop over time, we see that they follow different paths. Fluid intelligence tends to decline as we get older, while crystallized intelligence generally improves. Although we don't fully understand why fluid intelligence decreases, it is likely linked to changes in the brain. The increase in crystallized intelligence suggests that most people continue to gain knowledge throughout their lives, at least until late adulthood. So this is a diagram that shows developmental trends in psychometric intelligence. And this is based on performance on tests used to define fluid, crystallized, and general intelligence as a function of age. And so throughout life, our general IQ tends to remain stable. Tests of fluid intelligence tend to decline as we get older. However, tests of crystallized intelligence show that our crystallized knowledge and intelligence tend to improve. The parietal-frontal integration theory suggests that intelligence arises from a distributed and interconnected network of neurons in the parietal and frontal lobes of our brain. According to this model, there are differences in intelligence, and differences among individuals can be traced back to variations in the brain structure and function. This model has been supported by several studies that show there's a connection between measures of fluid and crystallized intelligence and specific brain structures. While certain general processes and brain regions are linked to intelligence, there isn't a single area that corresponds to specific abilities. Another theory based on neuroscience is the neural efficiency hypothesis. This theory posits that more intelligent individuals process information more efficiently, showing less brain activation in fewer areas compared to those with lower intelligence. Research is increasingly supporting this idea, indicating that higher intelligence is associated with a greater efficiency in neural processing. However, we still don't fully understand how this neural efficiency develops or what the pathways are for its development. One key question in understanding intelligence is whether differences in performance are due to actual age-related change or mainly to generational differences. On one side, many cross-sectional studies show that intellectual performance tends to differ with age. However, there are several longitudinal studies that show there may be no decline in performance or even an increase as people age. A challenge in determining if cohort effects are influencing these outcomes and differences is ensuring that the tests used are relevant across generations. So for example, if a test focuses on using the latest social media or understanding new terms, younger people are probably going to perform better simply because they are more familiar with that content. Whereas older people may have a harder time understanding or answering questions that have to do with social media because they're less likely to use it. This doesn't necessarily mean that intelligence has declined in older generations. It just might reflect that there are biases in the material being tested. In longitudinal studies, people are tested multiple times, which can lead to practice effects, and this means that repeated testing might make it seem like performance is improving, especially up to age 65. To better understand these differences, researchers can compare data from several samples of people born in the same generation but tested at different ages. When this approach is taken, it suggests that some of the decline in intelligence test performance with age might actually reflect generational differences rather than true age differences. And these generational differences are often linked to better education, healthier lifestyles, improved nutrition, and better healthcare among more recently born cohorts. However, interpreting data from cross-sectional studies is complex because they mix age and cohort factors, which make it hard to draw clear conclusions. Several researchers propose that general processing constraints associated with aging may contribute to declines in fluid intelligence as we get older. So, for example, studies indicate that processing speed plays a significant role in the decline of both fluid and crystallized mental ability starting in middle age. Additionally, the decline in working memory with age can hinder older adults' performance on tasks that require them to coordinate new information with stored knowledge, which is essential for fluid and mechanical intelligence. Finally, older adults may struggle with inhibiting actions and thoughts or avoiding interference, which can also affect their efficiency in fluid and mechanical abilities. Sociocultural and lifestyle factors are linked to intellectual functioning. Research has explored how the cognitive skills demanded by different occupations can impact intellectual development. If a job heavily relies on certain cognitive abilities, individuals in that role may be less likely to experience declines in those skills as they age. And so differences in cognitive skills are needed in different occupations, and that can make a difference in intellectual development. Several demographic factors also contribute to slower rates of intellectual decline. These include having a higher socioeconomic status, being exposed to stimulating environments, and having access to cultural and educational resources throughout adulthood. Additionally, maintaining strong social connections is important. There are some studies that show that poor social relationships are linked to faster cognitive decline. Several personality traits are considered important for understanding changes in intelligence. One key aspect is self-efficacy, and this refers to a person's belief in their ability to maintain their intellectual skills. Research shows that older adults who believe their actions can help them stay sharp are likely to perceive their abilities more positively. Specifically, those with strong initial fluid abilities and a high sense of control tend to have better perceptions of their skills, while those with lower abilities may feel worse about themselves. Having positive beliefs and attitudes can also lead to behaviors that enrich cognitive abilities, such as exercising and seeking mental challenges. Studies suggest that people with flexible attitudes in middle age experience less decline in their intellectual abilities compared to those with more rigid views. Additionally, being open to new experiences, which is another personality trait, may help protect against declines in fluid intelligence. And this is because open individuals often receive more stimulation from their environment, which can enhance their crystallized intelligence. There's also a connection between health and intelligence, which is clearly seen in how the brain functions. So as we discussed in Chapter 2, aging brings about certain changes in brain structure that can affect how well it works. Additionally, in Chapter 6, we highlighted how factors such as brain injuries, nutrition, and overall health can impact cognitive functioning. So disease such as dementia can severely disrupt brain function, while conditions such as cardiovascular disease, cancer, and diabetes can have significant negative effects. Cardiovascular disease in particular has been extensively studied for its impact on cognitive functioning. And researchers suggest that this disease contributes to a pattern of cognitive impairment, and it's partly due to its effects on the prefrontal cortex. There was a large longitudinal study that involved over 20,000 people in the UK. The average age was 63, And the study results found that obesity in midlife and later years is associated with increased inflammation, high cholesterol, hypertension, and diabetes. And these conditions are linked to cerebral vascular disease, which can lead to structural changes in the brain and cognitive deficits. Physical exercise can have significant benefits for maintaining cognitive health and slowing cognitive decline once it starts. There was a study of 228 older adults without atypical cognitive performance, and the results showed that engaging in moderate to vigorous physical activity was positively associated with fluid abilities such as perceptual speed and reasoning. And so this aligns with existing research that aerobic exercise does have a lot of benefits on basic brain function. Interestingly, the study also found that individuals who spent more time sedentary performed better on vocabulary and reasoning skills. So activities such as reading and solving puzzles can enhance vocabulary and reasoning skills. And these are typically done while seated. And so this study did make sense. The link between health and intellectual functioning is evident in the concept of terminal decline. And terminal decline refers to a gradual loss of cognitive abilities that occurs as a person approaches death. So, and even without dementia or other significant health issues, a decline in intellectual skills can be a strong predictor of mortality. Sherry Willis is a principal investigator and has greatly changed our understanding of how cognitive training can impact primary mental abilities. She created a long-term study called ACTIVE, which is the Advanced Cognitive Training for Independent and Vital Elderly. And the study explores whether age-related changes in intelligence are unavoidable or if they can be improved through cognitive training. The ACTIVE study started in the mid-1990s, and it became the largest research project to examine the long-term benefits of cognitive training on skills such as memory, reasoning, attention, and everyday activities. The results show that cognitive training helped improve mental abilities and daily functioning in older adults living independently, and these improvements lasted for at least 10 years. This was especially true for training in reasoning and processing speed, but memory training didn't have the same positive effects, particularly for those with even mild cognitive impairment. There was another study done by Edward, and he found that training to improve processing speed reduced the risk of dementia by about 29% over 10 years. And so these findings suggest that while some declines in mental abilities can be improved with training, not all abilities benefit in the same way, and the improvements don't always carry over to other untrained skills. However, there is strong evidence that older adults can still gain a lot from training, and this can slow the decline in some mental abilities and possibly delay dementia. The benefits of training often don't transfer to other areas unless training focuses on skills such as executive functioning and working memory. But overall, there is hope that some of these declines can be slowed or reversed, and no one is too old to benefit from cognitive training. So we'll explore Piaget's theory. His theory represents cognitive structural approaches to understanding intelligence. According to Piaget, intellectual development is about adapting through activity. We shape how our knowledge is organized, which ultimately influences our thinking. Piaget believed that intelligence develops through increasingly complex cognitive structures. And his theory of cognitive development transformed how psychologists view intellectual growth. For Piaget, thought is guided by two main principles. There's adaptation and organization. Adaptation involves adjusting our thinking to fit our environment. Just as animals in different habitats eat different foods, our thinking evolves based on different developmental contexts. This adaptation happens through organization, meaning that various parts of our thinking are structured and work together. In Piaget's view, cognitive structures change throughout our lives and determine how we think. Piaget identified two key processes. One is assimilation and the second is accommodation. Assimilation is when we use what we already know to understand new information. So for example, a child that knows the word dog might call every animal they see a dog. So if the child sees a cat and calls it a dog, they're using their existing knowledge to make sense of the new experience. Accommodation is adjusting or changing our thoughts to make a better approximation of the world. So it's about adjusting our thinking to reflect the world around us. In our example, when the child learns that a cat is not a dog, they update their understanding and create a new category for cats. And so this means that they've accommodated their knowledge to include this new information. Piaget's research led him to identify 4 stages in the development of mature thought. One is the sensory motor stage. Second is the pre-operational period. Third is the concrete operations period. And lastly, the formal operations period. In the sensory motor stage, this is the very first stage of cognitive development. And this is where intelligence is demonstrated through infants' actions. Babies learn by using their senses and motor skills, and they start with basic reflexes such as sucking or grasping, and they move to intentional behaviors such as searching for a hidden toy. A key learning in this stage is object permanence, and this means that babies understand that objects still exist even when they can't be seen. The second stage is pre-operational, and during this stage, young children become egocentric. And this means that they believe everyone experiences the world the same way they do. So for example, a child might think that a doll feels pain. While they can sometimes reason through situations, their thinking isn't based on logic. So for example, a child might think that shaving causes the tap water to turn on simply because they always see these actions performed together. The next stage is the concrete operations period. And here, logical reasoning starts to develop. So we see that children are able to classify objects into groups, such as fruits or vegetables. We also see that they're able to reverse sequences of events in their minds. We can also see that they understand conservation. So this means knowing that changes in one area are balanced by changes in another. They can also grasp transitivity. So if A is greater than B and B is greater than C, then A is greater than C. They can still struggle with abstract concepts such as understanding love and really viewing it only in terms of specific actions. The last stage is the formal operations period, and at this stage, Piaget believes this marks the end of cognitive development, and this is typically seen in adolescence. Formal operational thinking includes 4 main aspects. Hypothesis testing approach to problem solving, which is known as the hypothesis deductive reasoning, thinking within one framework at a time, aiming for a single correct solution, and being unconstrained by real-world limitations. When older teens and young adults encounter real-world problems, they often think differently. Adolescents and younger emerging adults usually approach these problems in a formal, logical way. They might point out that the student handbook clearly states the rules, and since the student broke a rule, they conclude that the student should be expelled. Their reasoning feels right to them because it's based on their understanding of the rules and logical steps. In contrast, many emerging and established adults, especially those who are middle-aged or older, hesitate to make quick decisions based on limited information. They recognize that the situation can be interpreted in various ways. So they might ask questions like, has the student been taught how to properly use sources? Did the teacher clearly explain what plagiarism means? For these adults, the situation is more complex and they consider many factors beyond what's presented. Researchers have found that this different way of thinking reflects a qualitative change that goes beyond formal operations. This new way of thinking is called post-formal thought, which recognizes that the truth can vary depending on the situation, that solutions need to be realistic, and that ambiguity and contradiction are common. It also acknowledges that emotions and personal factors influence thinking, and that well-reasoned conclusions come from careful consideration. One of the best ways to describe how adults develop their thinking is through the concept of reflective judgment. This refers to how adults reason through real-life dilemmas involving topics like personal experiences, politics, identity, religion, science, and relationships. So this following table gives you a description of the stages of reflective judgment. The first three stages of this model are known as preflective thought and reasoning. In these stages, people usually think that every problem has a clear-cut, correct answer. So for example, a student asking a teacher for the right theory to explain human development will show this kind of thinking. People at this level often hold strong opinions on controversial topics without recognizing that other people can have different viewpoints, and it's okay for others to disagree and still have valid opinions. As people progress into the other stages, their thinking starts to shift into what's called quasi-reflective thinking. And in this stage, they begin to believe that nothing can be known for certain. And they base their conclusions on personal experience and the current situation. And they start to see knowledge as something subjective, meaning that there is no single truth. They become less forceful in their opinions on controversial topics and often say that everyone has their own perspective, therefore I can't impose my views on others. As individuals continue to develop, they move into true reflective judgment, also known as reflective reasoning. In these stages, they understand that knowledge is constructed through careful analysis of problems and consideration of multiple viewpoints. They can hold strong beliefs, but these are formed only after thoroughly examining different perspectives, and they're open to reevaluating their views as new information and data come in. So they realize that knowledge claims cannot be made with certainty. They're considering multiple viewpoints in order to reach a conclusion about something. So in summary, post-formal thinking is a movement that shifts our cognition from believing I'm right because I've been through this to I'm not sure who's right since this person's experience is different from my experience. And then finally to I believe this because I've thought it through from different perspectives. And so I'm not going to make assumptions because both things can be true at the same time. My experience can exist, their experience can exist. Data shows this, and I'm going to draw this conclusion based on all of these different experiences and perspectives. Problems that seemed simple in adolescence become more complex for adults, making it harder to determine a right course of action. So in adult thinking, there's finally a recognition where people start to realize that you can have multiple right answers that can coexist. There is no single right or wrong answer. People start to realize there are multiple perspectives to a problem. And they start to blend their emotions with logic. So as people age, emotional development runs parallel to intellectual growth, bringing both gains and losses. As adults mature, their decisions are influenced not just by logic, but also by practical and emotional considerations. They see rules as relative rather than absolute. They can understand that thinking involves social interactions, compromises, and acceptance of contradictions. Deciding on personal principles often results from this mix of thought and emotion, considering various viewpoints to an argument. So, for example, late adolescents or young adults may see unethical behavior at work as completely unacceptable, and they believe the employee should be fired. In contrast, established and middle-aged adults might consider the context and reasons behind the behavior. So they may not jump right away to conclusions and say, well, this person should be fired because they broke the rules. They are weighing the pros and cons and looking at potential reasons why this person may have broken the rules. And so this difference could stem from emotional weight of the issue, where older adults are better at integrating emotions into their reasoning. And so somebody that has been fired before may have a certain level of empathy for that person, or maybe they are able to understand why this person was performing unethical behavior or doing things a certain way at work that would have led to their behavior. As people age, two key things happen regarding integration of emotion and thought. First, older adults can use their rich emotional experiences effectively, as I mentioned earlier. And this makes it easier to blend emotions with reason. In more challenging situations where arousal is high and the demands of the task are great, strong emotions can limit their ability to integrate thoughts and feelings. There is some neuroimaging evidence that shows that emotion and logic is integrated and occurs in the prefrontal cortex and anterior insula. The amygdala, which is another deep brain area, is also playing a role in processing emotions, and it connects with thought as well. These connections between emotion and thought can help us understand what happens when these pathways are changed or missing. Studies have shown that these connections are different in people with certain mental disorders. This means that while adults without mental disorders have similar pathways for thinking and feeling, those with mental disorders have different pathways. So in this chapter, we learn that people's fluid intelligence, which helps them with thinking and problem solving, declines in several areas as they age. On the other hand, crystallized intelligence, which is based on life experiences, often continue to grow or at least stay the same until later in life. Adults also tend to think more integratively, which means they combine emotions with logic. And this suggests that their decision-making and problem-solving abilities can be complex. Research shows that older adults often make less effective decisions, using less optimal strategies, and struggling with tasks that require holding a lot of information in mind at once. And so older adults tend to not perform well when decision-making involves a high degree of working memory capacity. And so in everyday decisions, a lot of the times, decision-making does not have tight time limits, which allows older adults to take their time and seek advice from other people. This can help them cope with changes in their cognitive abilities. So for example, they might write down information to keep track of their options, which can lessen the effects of age-related declines that are seen in research studies. When examining decision-making, we find that older adults tend to gather less information, we require less to make decisions, avoid risks, and rely on easily accessible information. And this pattern holds true across various situations, from grocery shopping to financial planning. A particularly complex decision for older adults arises in the context of chronic renal disease. About 25% of patients with end-stage renal disease are older adults. They must decide how to manage their condition, and they often weigh options such as dialysis or a kidney transplantation, which may not always be available. Many older adults have other health issues that can affect their decisions and lead them to choose conservative care instead of dialysis. They realistically evaluate their treatment options based on their health, the available resources they have, and personal situations. So when decisions involve areas where someone lacks extensive knowledge and does not know what to do in a new situation, they tend to rely more on basic mental processing, which is known as fluid intelligence. And this is where we see age differences are most likely to occur. And this is because older adults' fluid intelligence tends to decline as they get older. In contrast, when decisions rely on learned knowledge and experience, age differences are less pronounced. And so we see that older adults actually tend to gain more crystallized intelligence as they accrue more knowledge and experience in everyday life. When older adults recognize that decisions are personally important, this awareness helps them focus better on key information, making them less vulnerable to fraud and exploitation. Emotions also influence age-related differences in decision-making. Negative emotions like anger and fear can arise during important high-stakes decisions. Research suggests that older adults aim to reduce negative feelings and enhance positive ones. So, for instance, older adults tend to focus on positive aspects when making health-related decisions. And they also tend to focus on positive aspects in prioritizing their options that improve their quality of life and allow them to spend time with their loved ones. Older adults also tend to concentrate more on positive information than younger adults do when explicitly asked to evaluate their options before making a decision. However, if they aren't prompted to reflect on a decision, there are no significant age differences in their decision making. One of the key ways that people use their thinking skills is to solve problems in their daily lives. Think about how often you may face problems in school, work, relationships, or even while driving. Each situation requires you to quickly analyze what's going on, using your knowledge and coming up with solutions, sometimes in just a few seconds. Some people are better at handling certain types of problems than others. And so the question is, why could this be? One reason could be that we often rely on abilities that we use regularly versus those we use only occasionally. So, for example, practical problems that we encounter in everyday life are different from more abstract problems that are found in specialized settings like research labs. It's likely that adults perform better on practical problems than on abstract ones typically seen in standardized testing. And so, for example, consider a scenario where someone is frying chicken and a grease fire starts. What should they do? To study practical problem solving, researchers have created tests that reflect real life situations. And so one test is known as the observed tasks of daily living. And this test assesses skills in areas like cooking, taking medication, and using a phone. This test also helps determine whether someone can live independently. Research shows that age, fluid intelligence, and crystallized intelligence all influence how well people perform on this observed task of daily living. Other factors like memory and health can also play a role. So studies do indicate that skills like reasoning, specific knowledge, and cognitive strategies are important for everyday problem solving. Additionally, our ability to solve problems changes as we age, and it's also partially shaped by our experiences. So, for example, older adults might use different strategies depending on the type of problem they're facing, like using emotional regulation in family conflicts, but opting for direct action in practical issues. On the other hand, younger adults tend to apply similar strategies across different situations and often try to fix problems directly. How we define problems can vary with age and cultural background. Middle-aged and older adults often focus on relationship goals, such as improving connections with other people, while younger people might prioritize competence goals, such as doing well in school or sports. This shows how our approaches to problem solving evolve over time based on our experiences and life goals. From a practical standpoint, we all become experts in areas that matter to us, like our jobs, relationships, cooking, or whatever we enjoy doing. An expert is someone who is significantly better at a task than those who haven't invested much effort into it. We often specialize in some areas while being beginners in others. And so one question is, what makes experts significantly better than novices? It really comes down to how they approach problems. Novices usually aim to quickly reach a satisfactory performance level that feels stable and independent. On the other hand, experts have accumulated a wealth of knowledge about different ways to solve problems or make decisions. And this deep knowledge is the key difference between experts and novices, which allows experts to skip steps that novices follow. Experts don't always stick to the rules like novices do, and it's because they are more flexible, creative, and curious, and they use advanced strategies that are based on their extensive knowledge. Even if experts take longer to plan, their ability to bypass certain steps gives them a significant advantage. And this shows how having knowledge can often be more beneficial than just relying on straightforward reasoning. Research shows that expert performance usually reaches its highest point by middle age and then experiences a slight decline afterward. These declines, however, in expert performance are much less significant compared to the decreases seen in information processing, memory, and fluid intelligence, which support expertise. In some cases, having expertise can help offset declines in cognitive abilities. Lifelong learning is essential for maintaining cognitive activity and is considered a key part of overall cognitive health. So as people age, their preferred learning methods may change, and so effective lifelong learning involves making informed choices about how to keep knowledge current and which learning approaches would work best from many options available. Models of lifelong learning now incorporate research on cognitive changes related to aging, how AI can personalize learning experiences, and how online access can provide learning opportunities for those who previously lacked chances to enhance their skills. Lifelong learning also plays a significant role in addressing sociocultural issues related to aging. So, for example, it can support the development of age-friendly organizations by fostering multi-generational learning and knowledge sharing. As individuals increasingly move across the borders, the concept of transculturalism emerges. And this involves examining how transnational migration can influence culture, identity, and integration among diverse populations. Transculturalism represents a new way of learning and interacting in a culturally dynamic environment. So we're going to briefly cover aspects of creativity and wisdom. In terms of creativity, there's no single definition for it that everyone agrees on. Some would define it in adults as the ability to produce work that is new, in high demand, and suitable for the task. Others emphasize the creation of valuable and unexpected ideas, while some focus on the combination of imagination, intention, and action. Creative output is measured by the number of creative ideas or significant contributions. And this varies throughout our adult life and across different fields. And we see similar trends in creativity in various sociocultural groups. Typically, creativity does show a decline starting in midlife onward. However, this does not mean that people stop being creative. Rather, they tend to generate fewer ideas than they did when they were younger. Creativity isn't solely linked to age. In fact, experience plays a crucial role in creativity and innovation. And experience can help individuals recognize when traditional methods are no longer effective or useful, and they can understand their knowledge gaps and how to address them. Since creativity arises from the interaction of cognitive abilities, personality, and developmental factors, it persists throughout life. Recent neuroimaging research shows that the brains of creative individuals function differently. For instance, it suggests that creativity involves both the static and dynamic reconfiguration of brain networks tied to complex cognitive processes. So in this figure, we see a typical lifespan trend described for painters and composers. And this is based on creative output, which is the number of creative ideas a person has or the number of major contributions a person makes. And this varies across the adult lifespan. And so we see in this trend that output tends to increase through a person's 30s, peak in the late 30s to early 40s, and then decline afterwards. So we're going to briefly cover wisdom and 4 characteristics of wisdom. There is extensive research involving in-depth interviews with young, middle-aged, and older adults about various everyday and complex problems, which has led Baltes and his colleagues to identify 4 main traits of wisdom. And there is no unified definition of wisdom, because it really does depend on the person's sociocultural context. However, there are 4 main traits. One is that wisdom deals with important matters of life. It addresses important and difficult issues related to life and the human experience. Second, it is truly superior knowledge, judgment, and advice. And so people that have higher levels of wisdom have a higher level of knowledge, sound judgment, and are able to give valuable advice based on their experience. 3, wisdom encompasses knowledge that is extensive, profound, and balanced, which makes it applicable to specific situation. And so people who have higher levels of wisdom have more scope, depth, and balance. And lastly, wisdom, when it is applied, it is motivated by good intentions and combines intellect with moral character. And so people with higher levels of wisdom tend to be well-intended, and they are able to combine mind and virtue. Now, according to Grossman in 2017, wisdom is not simply a personal trait, but it is instead influenced by specific situations. And so whether someone is considered wise can depend on the context, and there is no overarching wisdom factor. So there is not like this universal wisdom factor. Wisdom is also not shown to be associated with age as well. According to Grossman, they offer a thorough explanation of this consensus model, which highlights 4 key traits of the knowledge associated with wisdom. And so one is intellectual humility, which means a person with higher levels of wisdom are more likely to acknowledge the limits of their own knowledge. Number 2 is perspective taking. So this means recognizing other people's viewpoints and the broader context surrounding an issue. And so the more knowledge a person has, the more a person can recognize other people's perspectives and the context they're coming from. Third is the acceptance of uncertainty, which means understanding that change and uncertainty are a part of life. And then lastly is integration and compromise, which includes combining different opinions and favoring compromise. And so together these traits reflect metacognition, which is our awareness and understanding of our own knowledge.